Hello everyone. In this video, we are going to briefly talk about MEX files in MATLAB. So the explanations here are coming from MathWork and a little bit at the end from Wikipedia. So MEX stands for MATLAB executable, okay? And it's a file that you can run from MATLAB, but it's not a regular MATLAB file. It's basically MATLAB using the code that is already written in C, C++, or Fortran, and you want to use those code written in a different language, you want to use it in MATLAB for many different reasons that we can discuss. But the good thing about it, so they are not .m files, but once you convert them to MEX file, which is basically a binary file, okay? So MEX files are binary files that directly are executable. Then you can call them the same way that you can call a MATLAB function. Just pass them inputs and they're going to give you the outputs. Okay? So why would you possibly convert the code written in C or Fortran into something that you can run in MATLAB? The big one is using the large existing routines or functions or scripts that are written in C and Fortran in the past, with people who did not use MATLAB. They just directly wrote it in C or Fortran, and you don't have anything equivalent of that in MATLAB. If you want to use them in MATLAB, you can basically, without rewriting the code from scratch into M files, you can just directly use them. The second one is the speed. And I have to talk about this speed, and I'm going to show you a demo, but in general, you know that in general, C++ and C are faster than MATLAB, because MATLAB is an interpreted language, C, C++ are compiled. So they first do the compilation, and when they compile, then the speed of running codes, especially if they have loops, they are quite a bit faster in C++ than MATLAB. So if you can convert those C code into a binary, then you can speed up your MATLAB computations, and then you might talk about parallelism, which is not really the most important goal, but if you want to write multi-threaded with several processors C code for operations that cannot simply be vectorized, you can also use that. But the main reasons are typically 1 and 2. Okay, and again, one more time, I confirm that these are binary things that are compiled and directly can be used. So what are the parts of a MEX file? So a MEX file has 3 major parts. The first one that you see on the top is called the gateway routine, which is called MEX function. And the goal of this gateway routine is to interface between C and MATLAB. Okay, because the way that the inputs, outputs, and the data are handled in C and MATLAB are a little bit different. So this MEX function makes sure that your C code can still be used in MATLAB or your Fortran, okay? So it basically counts as the entry port to the MEX file, okay? And and then you can say that the MATLAB accesses the rest of the code in your MEX files through this MEX function. The format for it, the signature, or you might call the syntax for it, is something like this: void MEX function, and then what you pass to it is the type of the variable NLHS, MX array, star, asterisk, PLHS, and so on. So what are these? So here there are 4 arguments: n, which is the number of, and then LHS, which is the left-hand side, and n, the number of right-hand side. So these are the number of left-hand side and the right-hand side arguments, which basically, you know, when you write a function, the inputs are on the right, the outputs are on the left. So NLH is the number of outputs, and NRH is what? Clearly the number of the left-hand side, which are the outputs. Okay? Yes? So when it says the left side arguments, we are talking about what? We are talking about inputs. And when it says the right-hand side, and when we talk about the left-hand side, then we are talking about what? The outputs. So this is just the number of inputs and outputs. In MATLAB, the commands are narg in and narg out. And then the variables that will sit into place of inputs and outputs, we call them P of right-hand side and P of left-hand side. Okay, so these are the arrays of the left-hand side and the right-hand side what input-output arguments. Okay, in MATLAB you might call them, for instance, if they are variable, you might call them var arg in and var arg out. Or if they are fixed, for instance, you say something like y1 and y2, right, equals, for instance, my function of input or u1 and u2 and u3, right, something like this. So now this number of left-hand side argument is 2, the number of right-hand side argument is 3, and then P of left-hand side is y1 and y2, and P of right-hand side is u1, u2, and u3. Okay, so these are input and outputs. And they could be integers, they could be anything else. Another important thing that you make sure when you use is in MEX files, we typically use the pointers. So when we want to handle an input or output, we use their pointers, okay? And not directly the name of the variable, we use the pointer of that variable when we want to do some manipulations, some calculations or something. And if we want to make sure that they do not change through the execution, then we add this constant to it. So when we say constant max array equals something, that means do not change that during the execution of the code, right? So I have added some extra things here. You can see that it says declare these input and output arguments as MEX array and with a pointer, which means they point to MATLAB arrays. Okay, so they are vectors that contain the pointers. The keyword constant, as I said, it modifies it, which means the MEX file does not modify that input. Yes, so that is important. And again, here is further explanation that the input arguments are typically read only when we do not modify them in the MEX files. Okay, we just create a copy of them basically. And if you want to create a copy separately, then there is this function in MATLAB called MEX duplicate array. So if you want to create a copy of input, then you can use this one as well. Or if you say constant means, hey, my goal is not to modify it, is to use it to generate the output, not to modify the inputs, okay? So these are some important things you need to have in mind. So the first part of the MEX file, as I said, is a gateway routine, which handles the interface between C and MATLAB and handles the inputs and outputs, right? And it always has some sub-routine that will check the number of inputs and outputs and throw error at you if the type of these variables or the number of them are not right, okay, as I'm going to show you. Then we have the major part, which is the computational routine, which is basically, you call it from the gateway routine, that this is the major thing that you want to do. So here in this example that I showed you, if for instance, y1 is u1 plus u2 plus u3 and y2 is, let's say, u1 times u2 times u3, then that part of the code is going to be here in the computational one. And then if you have any preprocessor macros or anything like that, and you want to make independent, platform independent code or anything, that can go at the end. Most of the time, we don't need to deal with that. We just need to make sure the interface is right, the number of input outputs, their types are right, and then we put our computation. Good? So if you want to see examples of C++ MEX files, the files that are written properly and they're just directly ready to be compiled, if you want to see them in MATLAB, go to where MATLAB is installed, go under external examples cpp.mex. Here is that folder on my computer, and you see there are some CPP ready for compiling to MEX files that are there, okay? So as I said, when you're writing a CPP code to be converted to MEX, you have to add some extra stuff. It's not just like writing a simple CPP code. Even for a simple operation, for some simple computational routine, you have to add a bunch of extra stuff before it could be compiled into something that MATLAB can use. So let's take a look at this one. This is called array product, and all it does, it multiplies a constant scalar, a multiplier, by the components of an array and gives you the result. So if you give it a constant c and vector a, the result is c times a. Okay, it's very simple, but if you look at all the code that is there just to do that basic thing, you see it's like 60 something plus lines of code, or 50, 60 lines of code, and all the computation is simply done here. That's all the computation. Look, 3 lines. The rest of it is just input, output handling, and proper interface. So writing a MEX file could be what? Could be a little bit a daunting task. Now, the important thing you need to add is, first, you need to add these two libraries, mex.hpp and mexadapter.hpp. This is your gateway routine. You see, class MEX function. And what is it that it is doing? So what it does is it looks at the outputs and inputs. The first thing it calls is the subroutine check arguments. It takes the outputs and the inputs of the MEX function and pass them to this function check arguments. What does check argument do? Look, it says, hey, if the input dot size is not equal to 2, then say 2 inputs required, because remember, you need a constant c and a vector a. So if you just provided 1 input, it is going to pick on you. If input.0 get number of elements is not equal to 1, so if the number of what entries in the first input, which is the constant, if it's not equal to 1, so the first element, instead of being a constant, is a vector or a matrix, then say, hey, input multiplier ought to be a scalar. If input.0 get type is not equal to MATLAB double, so if the scalar is not a double variable, okay, or it's not a complex double, then say, hey, it has to be a non-complex scalar double. Okay, you see that? Actually, it says if it's not equal to double or if it's equal to a complex. Okay, these two are different. Yes? So if it's not double or if it's a complex, for instance, if you use the complex multiplier or use a character or anything other than a double, it is going to pick on you. Yes? Then now you go to the vector, input number 1. Remember, C indexing starts from 0. So now the second input, which is the vector, the type of it is definitely has to be, again, double, no complex. And also, if dot size of that is not equal to 2, then you have to say the dimension should be m by n. So if it's a scalar, it does not have 2 dimensions, a number of rows and a number of columns. And in this case, of course, one of them is just 1. But guess what? Here, you're going to pick on it and say, hey, input must be m by n. So you see, all of this huge portion of the code is simply what? Checking arguments. And when that is done, now you take the input number 0 and call it multiplier, the constant, and then what? You take basically the input number 1, okay, transfer it to this variable called in. So in is your vector. In is your vector, multiply is your scalar. Make sure it's a typed array of type double under MATLAB data. Then call the computational subroutine array product. You pass to it the vector in and the constant. And what does that one do? Let's take a look now here. So it takes in from you the in matrix and the multiplier, and they are both double. Then what? Then for elements in matrix, for each and every one of the entries in matrix means what? Means the input matrix. Element asterisk equal multiplier. What does that mean? Means element equals whatever it was times the multiplier. So you see, that's all it does. Multiply each and every element in the in matrix by multiplier, and then what? It does not return anything. It does not return anything. So what does it do? If it doesn't return anything, what does it do? It modifies the in matrix for you. It modifies the elements of the in matrix. So this array product is not going to give you a new output, which is multiplier times input. It's going to modify the input to be whatever it was times multiplier and just modify the input. Now, how would you modify the input and not create a copy of that here by this ampersand, by the address? So you go to that address and directly manipulate the memory here. You're not going to create a local copy for this function. You're directly going to manipulate that in matrix values. So in the memory they change. So now you say what? That's an input, that is the new changed vector. Set it to what? To output.0. Set it as the first output of my function, and that's it. You see? So this is like your main in C++. It checks the arguments, does the operation, defines the inputs and outputs, and it is using its subroutines, its utility functions here, right? So you have to include all of that just to do some basic operation. That's why many people just skip using MEX files altogether, because writing that could be quite a bit daunting task. Okay, yes? So now, the first thing you need to do when you have this CPP file, it's not over yet. You might say, can I use this? No, this is a CPP file. You have to compile it into an executable. So how would you do that? First, make sure your MEX setup, and MEX is basically the command that is used for compiling. Make sure that the setup of it is correct. And what do I mean by setup? Well, this guy needs a compiler. It needs what? A compiler. And if you have a compiler from C to executable, then this is going to find it and it's going to use it. But if it cannot find a compiler that works with MATLAB, with C to go to binary, then you have to provide the name for it. So look here, when I run this command, you see, it says MEX configure to use Microsoft Visual C++ 2017. Okay, so that is on my computer, and that is acceptable by MEX. So it is going to pick it, and you see that it is going to work here. Okay, this top part is from my previous run of the code. So let me do it one more time for you here. Yeah. Now, if you want to compile a code from another language to a binary, for instance, you want a C++ separate, or you want a Fortran, if you want to compile Fortran, then instead of just saying MEX setup, say MEX-setup Fortran. Then you can compile from Fortran to executable. Okay? So this MEX setup or MEX setup C++ is just for C or C++. Right? Then, once the compiler is found and is confirmed, you can use the command MEX with the name of the CPP file. This is going to compile it into the binary for you. So now look here, when I run this, it tells me whether the building was successful, whether it could compile into, you see, the MEX completed successfully. So now I have a binary file. What's the name of the binary file? Let's go and look. That's this guy. It's called array product dot, instead of CPP, it's MEX Windows 64 bits. If your operating system is different, this extension is going to be different. But for me, Windows 64 bits is going to be MEX W64. So this is a binary file, okay? And if I double click on this file, nothing is going to happen. If I try to right click and open it, there is no opening here, okay? So that's just a binary file. And if I go here, look, it's this guy, and I try to maybe open it with the text editor or something, you're not going to see anything meaningful because it's just binary. You see here. Okay, so do not think that when you open it, you're going to see some beautiful C code or MATLAB code or anything. It's just a binary encoded. But this is going to work. You can directly call it from MATLAB. Let me show you. So now that this guy is the one that MATLAB can use, not the CPP one, this guy. How do I use it? Here. I have this scalar -5. I have this vector b. And for 1,000 times, I'm going to call it. And first time I do the multiplication in MATLAB, I simply say b equals a times b, right? The second time, instead of using the MATLAB code, I use this function. Look, I say b equals array product of a and b. You see, I overwrite it with the result of array product. And I do it for 1,000 times as well. Why do I do it for 1,000 times and I use tick-tock? Just to show you the execution time. So this is using MATLAB. And this is what? This is basically using the MEX file. And guess what? You think which one of them is faster? You might say definitely the MEX file, huh? Because it's using C. You will be surprised. Look here. Here I'm running it. See what happens. Look. The top one is MATLAB. The bottom one is MEX. MATLAB is about 10 times faster. And if you run it several times, so you get, each time you run it, you get different results. You see, always in this case, MATLAB is faster. Look at that. That's a huge difference this time. But it doesn't matter. I mean, all you need is just run this portion of the code. You don't need to do all that MEX and everything because we have done it already. So let's see. I do it again. Look here. MATLAB is 3 times faster. Again, these are going to be random numbers. We run it again. Look. MATLAB is 4 times faster and so on. But it's always MATLAB that is faster, to your surprise. You say, hey, didn't we use MEX to be faster? Not necessarily. Why is that? Why is MATLAB is not as fast as MEX? Well, the reason is this. Pay attention. So the fact is, most MATLAB functions, this part is from Wikipedia and it's important, and from this other part too. Most MATLAB functions are just wrappers for the code written in C or Fortran. That means a lot of built-in MATLAB functions, they simply use compile code, not interpreted code. So a MEX file does not always improve runtime. Many of the operations that you use in MATLAB, the built-in MATLAB functions, they are already compiled. And what you see, that is not a MEX or anything, what you see is just a wrapper, a layer, so you can interface with that compiled code and use it. So many of these functions are literally like a MEX file themselves, or even better, optimized. So MATLAB tried really hard to make their code run fast. And so they converted a lot of their functions into a wrapper of a binary. So many times you will be surprised that your non-optimized MEX code is not going to be better than the optimized wrapper of MATLAB. Okay, so don't always expect that. And just in case you want to say, what is wrapper? Wrapper here, wrapper library is just a thin layer of code which translate a library's existing interface into a compatible one. Okay, so for instance, if it's written for C, you just, this wrapper is make it such that it works with MATLAB. You create wrapper libraries for several reasons. One, to refine a poorly designed or complicated interface. The other one, which is what we are doing here, is allow the work to work together, the code to work together, which otherwise cannot, and enable cross-language and runtime interoperability. And this third one too. So here we are using it mostly for the third one and the second one. Enable cross-language interoperability to go from C to MATLAB. Okay, so unless the operation that you are using in MATLAB is not a wrapper and it's not optimized, and unless you write this CPP code very optimized and nice, do not necessarily expect your MEX code to be a lot faster. Okay, so mostly you might use it to use available libraries in C and Fortran that you don't have in MATLAB, and just bring those code in and work with them. This does not necessarily always means faster, although we mentioned this. That's why I said I need to explain that to you. So this is about writing a MEX file, and this is about how to compile it and how to use it. And you see that it simply is used just like a MATLAB function. Pass to it the inputs, it gives me back the output, although it's just a binary file, and it works fine. So hopefully this video was useful to you, and I'm going to see you in the next lecture. Thank you.